Good morning, my name is Gonzo, and this is part 2 of our soccer modelling from scratch in Python series. And today, we're going to start to think way more. We've gathered the data now. We've got a little bit of gardening to do in the code, but we'll come to that. We've now gathered the data, so let's think properly about the strategy for gambling on the market that we are going to put in place. And this is the very first basic one that we're going to use as a way to introduce ourselves to some of the mathematics and modelling that we need to gamble on sport and model it properly. We are going to write, over the next couple of videos, a strategy that exploits mispriced games. So where bookmakers disagree on the probability of like a win, a lose, or a draw for a team in a game, we're going to go ahead and exploit that. And we are going to use the information that we already have in our data set. So we are going to use Pinnacle's odds. So remember in the last video we imported the Pinnacle odds, the PSH, the PSD, and the PSA for all of the data that we pulled in. We are going to use them as a kind of source of truth. And there's good reason to do this, okay? They are what is known in the UK as an Asian bookmaker or a sharp bookmaker. They are notorious in the industry for being very, very accurate with their modelling. They take a lot of action, so they receive a lot of information about football games. And so we are going to use their odds kind of as a source of truth. But we can't just use them raw for reasons that I will show you in a second. We need to then take their odds and we need to reverse engineer the probability that Pinnacle assigned to the outcome of that event from those odds. And it's not 100% as simple as it seems. So this step has to happen. We need to reverse engineer the Pinnacle probabilities of a home or a draw or an away win. We then need to compare that with our available odds, and we need to calculate an optimal bet. In this video, we're going to do the first two, and then in the next video, we'll do 3 and 4. Right then, let's kick off with some light gardening. A commenter pointed out, which is a perfectly valid thing to do, by the way, and this person also reached out to me on TikTok. Thank you so much for doing that. Again, a perfectly valid mechanism of getting hold of me and talking about my videos, that we did not pull in all of the seasons. We missed one in the middle. You have to make sure that you've got all of them, okay? I think the one that we missed was 22-23, so just make sure that that is in your list just here. The other thing that person pointed out was that I promised that we would need the average of the home, the draw, and the away odds. That's actually not the case for this betting strategy, so we don't need them for now. If you wanted them, which we might do later, but I'm not 100% on that right now. If we wanted them later, what you would need to do is something like this. So if we look at our main DF, which we have that looks like this, we would need to take this object here, and in order to get the mean of the, say, the home bookmaker columns, we change this max here to just mean, and that gives us what the mean of the opinion of those bookmakers is. We're not going to worry ourselves with that for now, because it's not important for the betting strategy that we're going to work on, because we're only interested in the max. We want to know, like, what could we have got at kickoff? We're only interested in that. The final thing in terms of gardening is that you need these two libraries. You need NumPy, which is a number manipulation library, and you need matplotlib, which is a graphing library. I may be preaching to the choir here, like you may know those things already, but this is for very, very beginners, this set of videos. So in order to import those, you will need to use uvadd or ovadd. I've already done it with ovadd matplotlib, and then also ovadd numpy. It's very, very quick because I've already done it, but you will need to do both of those things in your terminal in order to be able to run the code that we're going to run today. Right, so thinking back on our strategy, the first thing that we need to do is we need to get Pinnacle's odds. So let's narrow down our data frame to something that we can hold in our heads and manage. So we're going to put this couple of lines back in, which reduce our data frame down to only the things that we need. And we need to do a bit of a trick for data handling, otherwise everything goes wrong in a minute. If we look at our data frame, you can see that there are 2,181 rows. And yet the numbers here in the index only go from 0 to 280. And that is because if we look at the individual data frames that make up this one big one, remember we get one for each season because we pulled them in our for loop last time. So we get a 1920, a 2122, yada, yada, yada. Each of those individual data frames at the moment has its own index from 0 to however many rows it has. when you stack data frames, the index is preserved by default. So the first thing that we need to do is we need to do a thing called resetting the index, which is we want our index to run from 0 to whatever the full number was, 2180. We can do that using reset index, and we're going to do that right here because there's basically no reason not to. So underneath where we create the max odds, we're just going to put in something that says main df.reset index, and then we're going to use a command called inplace, an argument called inplace, which is us telling pandas, I want you to do this on the data frame that I've just given you. Don't make a copy, don't do a new one. I want you to actually do this on the data frame that I'm talking about. So do it in place on main df. So you can see, let's compare and contrast. You can see right now it goes from 0 to 280. If we run all of this again with our reset index in place, we get from 0 to 2180. So thinking back on our strategy, what we need to do now, I'm looking at the board, this is why I'm over here, is we need to look at Pinnacle's odds. And naively, what you might think from that strategy is that we look at Pinnacle's odds, and if we can find a price that is higher, we just bet on it. So you can see in this instance here, for Liverpool versus Norwich, that for the home line, Pinnacle were quoting 1.15 for Liverpool to beat Norwich. The maximum we were allowed, so the maximum in the market was 1.15. That probably came from Pinnacle themselves or similar, anyone who was copying them. That happens in the gambling industry quite a lot. So we wouldn't bet on that. But here, look, West Ham are playing Man City, and Pinnacle quoted 11.68 for West Ham to win, and the maximum that we could have gotten from the market was 13. So naively, you might think, hey, we should have taken that bet. Let's look at what happens if you do that. So what we need to do is we need to isolate ourselves a data frame where, and we'll just look at home odds because that demonstrates my point, where the home max odds are greater than that quoted by Pinnacle. So let's call this the Pinnacle DF. So Pinnacle DF is equal to main DF, where main DF, and this is an index statement in pandas. This is how they are structured. We now put our condition in, so we want to know when is PSH less than main DF home max odds. So let's look at that, and now let's open that up, Pinnacle DF. So now we've got a new data frame of 808 rows, and this is all the instances from main DF where the home max odds are greater than the Pinnacle home line. So what happens if we were to bet on that? In order to figure out how we would have done if we bet on all of these prices, we need to use a conditional from NumPy called np.where, because we need to create ourselves a new column in this data frame, and this new column will be called profit. So Pinnacle df new column profit is equal to np.where. And what np.where does, the construction of this, okay, so you give it a conditional, so you give it like when something is bigger than something else, something like that, and then you say, here's what I want you to put in the column when this condition is true, and then here's what I want you to put in the column when this condition is false. So we want you, the conditional that we're interested in is I want you to tell me when the full-time home goals from Pinnacle DF are greater than the Pinnacle DF full-time away goals, because that is indicative of the fact that the home team has won. Okay, if the full-time away home goals are greater than the away goals, the home team has won. Okay, when that happens, I have won my bet. So my profit on that bet is equal to the value in Pinnacle DF home max odds minus 1, because it's the profit that we're interested in. So if we look at this bet at the top here where we've got 13 for West Ham versus Man City, if we had won this bet, I invest 1 unit of currency and I get 12 back to make the full 13. So no, I've misspoken there. I invest 1 unit of currency to have the option to win 13 back. So 12 is my profit, because remember I was holding 1 and now I have 13. If we lose the bet though, we lose 1 unit of currency. So naively, this is our first crack at this strategy. Let's have a look how it goes. We get ourselves a copy warning. Don't worry about that, doesn't matter. You can dive into the documentation and understand why you get a copy warning on pandas, but it's basically boring historic reasons that we don't need to worry about. If we then do a cumulative sum graph, so if we now do pinnacle df profit dot cumulative sum, so cum sum dot plot. If we plot this out, it'll tell us what happens to our bankroll if we just throw £1, 1 unit of currency, at every single one of these bets. What happens? Well, it doesn't go well, okay? Over the course of those 5 years, over these 808 games, you lose around about 40 units of currency, which is clearly like unacceptable, okay? This is not a good strategy. So we must be missing something. And we are. Okay, we've been naive. We have neglected to understand how Pinnacle construct their odds because we have to worry about something called the overround. In other gambling cultures, this might be called the margin or the vig or the juice, but basically it's the buffer of profit that bookmakers build into the prices that they quote. In order to understand how that works, let's grab one set of Pinnacle odds and start to reverse engineer them. Right, let's pick these three. For no particular reason. You can do this with any of them. In fact, I encourage you to do it with a different three to figure out what's going on. But we're just going to pick these three here because basically a whim. So we've got the three prices quoted for the three possible outcomes. So one of these lines is going to win. Okay? And in fact, we do know it won, right? Man City soundly beat West Ham 5-0. So this price paid out, the 1.26. Let's take these and roll down and understand the mathematics behind them. So 11.68, 6.53, 1.26. So if we make ourselves a new cell just here, we're going to say that the home odds equals 11.68. The draw odds, in fact, we'll just say odd. We'll call it odd because it is a single odd. Always weirds me out when I say it, but that's how it works. And then the away odd is 1.26. So, to get probabilities from odds, you just take the reciprocal. Okay, so naively looking at this, Pinnacle's probability for a home win is 1 over home odd, which is about 8.5%, 0.085. And their probability for a draw is 1 over draw and then 1 over away. And we're going to construct those and we'll look at what that means. So let's go home prob is 1 over home odd. Draw prob is 1 over draw prob. Can't spell. Prob, odd, sorry. Mine was somewhere else. And then away prob is 1 over away odd. Okay, now we know that the football game has to end with one of those three outcomes. All right, so the probability of home prob plus draw prob plus away prob should equal 1. And yet, if we add those three together, we will find that it comes out as more than 1. And that is because Pinnacle have built in a margin. So this is representative of the percentage of money that you would lose if you bet on all three outcomes. Because Pinnacle don't want you to be able to do that, okay? If you could show up to any given bookmaker and just bet on all three outcomes of a football game and make money, they would immediately go out of business. So what this is representative of is us seeing that Pinnacle have built in a 3% margin as profit for their odds. And this is how bookmakers work, right? Okay, this is like how sports bookmakers work, especially the sharp ones, especially people like SingBet and Pinnacle and the Asian bookmakers. What they try to do is they try to balance the market. So they attempt to price up their outcomes in such a way that they take the same amount of money on each outcome, and as a result, they will win on each, whatever happens, they will take about 3%. Different bookmakers have different sizes that they keep their overround at. Pinnacles is very small. All right, if you go to somewhere like Bet365 in the UK, you would probably see an overround of somewhere between 4 and 5%, sometimes even 6. If you go to an extremely soft bookmaker, I'm not going to name names here, but like Ladbrokes, okay, you might be seeing 7, 8, 9%, especially on really high-profile events that are designed to bring in recreational punters. Horse racing is wild for that, especially when there are very long odd outcomes that might happen. It is Cheltenham right now. There are some atrocious overrounds doing the rounds at the moment, which are just preying on the fact that people don't know enough about the gambling market to know that they're betting into something that is fundamentally a bad idea. We'll shout about that another time, but for now, we have to remove Pinnacle's overround. So there are different strategies for how you remove the overround, and they come down to the fact that we do not know where the bookmaker has assigned the overround in the outcomes that might happen. So you can do it in different ways. Pinnacle may have assigned 1% to each of the outcomes. So they have some probability that they have decided the home win is, there's some probability that the draw is, and some probability that the away is, and they might then add 1% to each of those outcomes, and then get a 3% overround on the whole thing, and so whatever happens, they win 1%. However, you might do it in a different way, okay? You might assign more overround to one of the results because you're more confident that that might win. So you might put 3% on all of the away win. So if away win happens, you win 3%. But then if draw or home wins, you win nothing as a bookmaker. You're just like paying out what you paid, what got paid in. We don't know what the bookmaker is doing, and so there are a number of different strategies that we can use to assign the overround. The three most popular are, let's just assume, the one we're going to use right now actually, which is, let's just assume the overround is assigned equally to all three outcomes. There's then, you can assign it in proportion to the odds. So because of long shot bias, which is a whole thing that you can go ahead and research for yourself, or we'll make a video about it sometime. But because of long shot bias, people prefer to bet on longer odds. People just like it, all right? And so bookmakers assign more overround to longer odds for two reasons. One, to make it more profitable if they pay out, and secondly, to restrict the amount that they're going to pay out anyway. And then thirdly, you can use what is probably the most complicated method, which is called Shin's method. Now, Shin's method is described here in this GitHub repo, and it was done, it comes off the back of some research that somebody called Shin actually did, which is a more game theory-led understanding of how the overround is assigned, where they're not just thinking about the bookmaker and their mechanics, but they're also thinking about what happens if you have like some unknown proportion of bettors that are insiders and have more information than you do. How do you then deal with the fact that that will distort the market, because it nearly always does in some way? We're not going to get into Shin today. We'll get into it later because it's pretty cool how the way it works, but we're not going to get into it today. What we're going to assume for now is that the overround is assigned equally to all three outcomes. So what we need is a function. We're going to write ourselves a function. Consulting my notes, I call it find true probabilities, because that's what we're doing. We want to know what are the true probabilities of the outcomes, and we're going to label it, because we'll make a few as we go on, but today this is the only one that we'll do. So find true probabilities equal. It's because we are assigning the overround equally to all outcomes. And what we're going to do is we're going to take a list of odds, and we are going to return an array, np.array of probabilities, adjusted probabilities. Okay, it is the next day because I got a phone call, so I had to jump. Let's construct this function. So we are taking in a list of odds just here, and we want to return this array, of adjusted probabilities. So the first thing that we need to do is we need to turn our odds into probabilities. So consulting my notes, probabilities, I spell that right, probabilities is equal to 1 over O for O in odds, like so. That'll give us, from our list of odds, a list of probabilities. So the thing that we've done there is we have done this logic on our list of odds. Once we have that, what we can do is we can find what is the total probability that we're dealing with. So probability is equal to the sum
of all of those probabilities. Let's just make sure that that is spelled the same as that, because historically that has been a problem for me. That is this step here and gives us whatever we have with our overround applied. The next thing we have to do inside this function is figure out what our overround actually is. So the overround is that total probability minus 1. That'll give us our like 3% number that we have been conjuring with. We want to then figure out what the adjustment factor is that we need to adjust our probabilities by to get the true ones. So the adjustment factor, and remember we are assigning this equally across all of our odds, is equal to the overround divided by the len of the odds. Once we've done that, we can figure out what our adjusted probabilities actually are. So adjusted probabilities equal, I'm furiously reading my notes because this is a reasonably nested thing to be doing, minus adjustment factor, for O in odds. That'll give us our adjusted probabilities. So if we read that function in, what we can then do is just check that it is true. So if we experiment on our odds that we have, and we're reading in a list of odds, so we know that we've got home odd, draw odd, away odd. This tells us that the implied probability from the raw pinnacle odds were different to what they actually were in reality. So the home prob as shown by the pinnacle odd was around about like 8.5%. In actual fact, once we have adjusted for the fact that there is an overround, it should really be about 7.5%. And that difference is going to be crucial for our strategy. So what we want to do now is we want to get this into our data frame. We want to construct 3 new columns inside our data frame for the probability of the home, draw, and away as calculated from the pinnacle odds once we have removed the overround. In order to do that, I have written a pandas apply piece of code, which takes this function and applies it to each of the rows to create these new columns. I'm going to do something I wouldn't normally do, which is to just copy and paste it straight in. And the reason I'm going to do that is it's a reasonably fiddly bit of code that if I'm talking and writing, I might just get wrong. So it looks like this. Let me talk through what all the different bits are doing so that you can understand how it's constructed. So we are creating 3 new columns: the pinnacle true home prob, pinnacle true draw prob, and pinnacle true away prob. In order to do that, we take our data frame and we are going to apply a lambda function. And what that lambda function does is it takes in a row, and a lambda function in Python is like a little anonymous throwaway function that we're going to use one time and one time only. So I don't want to give it a name. I like none of the garbage that comes along with functions and all of that heavyweight stuff, because I'm only ever going to do this once. It takes in a row and then it applies this find true probabilities equal function to that row. And I would like you to take in the PSH, the pinnacle sports home odd, the draw odd, and the away odd. And we want it applied along the row axis, which is what that's telling us. And I want you to expand the results, just like write them in place, that's fine. If I then run this and get the results of the main DF, we can have a look at those. And we now have 3 new columns on the end. We've got pinnacle true home prob, pinnacle true draw prob, and pinnacle true away prob. And they have in them the calculated probabilities from pinnacle with the overround removed. And we can stick in a check column as well. Let's just verify to ourselves that what is the total of that probability. So the main DF totes is main DF pinnacle true home prob plus, if we sum up all 3 of those columns, we should find that the total probability that we have should sum to 1. And it's always good to check your work in this way. Pinnacle true away prob And so if we then inspect main df, I'm sorry, that's my face is in the way. Ignore this garbage down here. This was me working out earlier that this was actually the way it was functioning. I am going to get rid of these things now so that they don't confuse you and they are not there next time because you will be following along. But if we look at main df now, we can see that the summed probability is 1. We're going to stop there. Next time, we are going to look into expected value of bets and something called the Kelly criterion, which is a way of calculating what is the optimal amount to bet on an outcome if you think you have a given advantage. We're going to stop here. Next time, we're going to backtest this. We need to use a slightly different backtesting engine than the one that we used previously, which was a vectorized backtest using cumulative sum. We now are going to have to write ourselves a for loop. It's a whole thing. Doesn't matter. We'll address it when we come to it. My name has been Gonzo. You should follow for more soccer content like this.